Hey, welcome. This video is on applications, word problems. I know we hear word problems, you get a little panicked, start sweating a little bit, heart rate increases. Yeah, it's not a big deal. Don't relax. It's the same thing we were doing before, just a few words. Actually, people tell me they enjoy these problems. Okay, so we're going to do two types of problems. The first one we're going to talk about is called the compound interest formula. Okay, so you might have used the simple interest formula I equals PRT. Sound familiar? But in reality, we really use a compound interest formula. And so here's our formulas in this box here. A equals P, and then in parentheses is 1 plus R over N, and then the exponent is N times T. Okay. P stands for your principal, the how much you invested. And A is going to be how much money you have after T years. So T is in years, and N is the number of times it's compounded per year, and R is your interest rate. Also keep in mind that the interest rate is in a decimal. So for instance, if it's 4%, then you would write 0.04. 8.5%, 0.085. You always move it over, you move the decimal point 2 places to the left to change from a percent to a decimal. Okay, I have some numbers here at the bottom. These are the typical numbers that are going to be used semi-annually. N would be 2. Semi-annually means twice a year. Quarterly, N would be 4 times a year. Monthly, N would be 12 times a year. Daily, 365. And annually, N equals 1. So these are how often you're going to get interest on your money, or how often the credit card is going to charge you interest. You know, credit card might be daily, right? Usually things are daily, but it could be quarterly or monthly. All right, let's do it. So find the amount of money in an account after 3 years if $5,000 is deposited at 8% annual interest, compounded quarterly. So some things to write down. Let's see. The 3, that's our time. So after you read a problem, jot down some notes to yourself. Jot down the information of what did they just give you. So 3, that's the time. And 5,000, that's your principal. That's how much you're investing or how much you're borrowing. That's like the beginning amount of money. And what we want to know is, what's it going to be worth after 3 years? Or how much are we going to owe after 3 years? That's a good question too. 8%, that's your interest rate. Remember to move it over 2 places to the left. And then compounded quarterly. What is N if it's quarterly? Right, 4. So write down your formula. A equals P, 1 plus R over N to the NT. And then replace those letters with the numbers given. And really there's no work for me to show you here. You just type it into your calculator. And that's it. It'll give you the answer. Since we're talking about money, you should round to the nearest penny. So round to the nearest hundredths. So you type it in just the way it looks. If you don't know how to use your calculator, well, you got to learn, right? So there should be some videos available. On my website, I have videos. If you're taking this, on my YouTube channel, I have videos. You could type in any calculator model you have and find some videos on how to use your calculator. Anyways, that's our answer, $6,341.21. All right, that was it. So just type it in and work it out. The next thing we're going to talk about is exponential growth and radioactive decay problems. You don't have to know any formulas or know anything about chemistry or biology. All we're doing is we're putting in numbers into a formula. So the Q sub 0 that you see there, that's read as Q naught. Not a German word or Gaelic word for 0. Maybe just English, I'm not sure. Anyways, Q naught. Time is 0. And in this video, K is already going to be calculated for you, so we don't have to worry about it. All right, so here's our first problem. The number of grams of a radioactive iodine, I-131, present after 2 days is given by the equation Q of T equals Q naught e to the negative 0.085 T, where Q naught is the initial quantity. All right, so here they tell us if the initial quantity is 150 grams, how many grams will be left after 7 days? So they're giving us everything on the right-hand side. You're going to rewrite it. Q of T equals, and instead of Q naught, replace the Q naught with 150, and replace the time, T's in days, and they tell us 7 days, so you replace the T with 7. So Q of 7 is the function. That's why it's written in this format, because it's just a function. Okay, so the Q of 7, nothing to do on the left-hand side. It's just saying that we're finding the quantity when T equals 7. So on the right-hand side, that's what you type into your handy-dandy calculator, 150, then the E button, and then you type all that stuff in the exponent, and it should give you 82.7. So our answer is 82.7 grams after 7 days. So this radioactive iodine might be a material that somebody gets if they have thyroid cancer. It's not really this kind of a dosage, not in grams, but that's the idea. All right, let's do another one. There's another problem, but it's worded a little bit different. So this is bacteria. This is a bacteria growth problem. There's our formula, Q of T equals Q naught e to the 0.4 T, and Q naught is the initial number of bacteria. If 8,000 bacteria are present after 12 hours, how many were present initially? So see what's different? They're telling us that there's 8,000 after the 12-hour time period, but we don't know the initial bacteria. We don't know how many we started with. So where is that 8,000 going to go? Right, it's going to go on the left-hand side. We don't know what Q naught is. That's going to remain Q naught. So here's our equation, 8,000 equals Q naught e to the 0.4 times 12. Well, we're in algebra. We have an equation. The variable is Q naught. We're trying to get the variable by itself. It's being multiplied by something. So how do we solve that? Right, we divide by it. So divide by e to the 4.8. 0.4 times 12 is 4.8, so we have e to the 4.8 on top. So you divide by e to the 4.8 on the bottom, and whatever you do on one side, you have to do to the other side. Okay. Type that into your handy dandy calculator, and you'll get your answer of 66. So there were approximately 66 bacteria initially. It might have not come out to 66 exactly, so we have to, with bacteria, we round to the nearest whole number. Okay, how long will it take 17,000 to be worth 55,000 if it is invested at 8% compounded daily? So another compound interest problem. That was the formula A equals P times 1 plus R over N to the NT. Now we do have $2 values. We're starting with 17,000, so that's our principal. That's P. And the amount that we're ending with is 55,000. All right, so let's write those numbers down. Write down our formula. The amount is 55,000 and the principal is 17,000. P is always what we start with, and A is what we end up with. The rate is 8%, so 0.08. Oh, it says compounded daily, 365. All right, plug those numbers into the formula. The only letter we don't know is T. That makes sense because how long is the question? That's T. They want to know what's the time. And I didn't put what to round it to, so we'll probably round to the tenths place. That sounds like a good idea. Okay, so first thing we need to do is divide both sides by 17,000. That way on the right it cancels. On the left, the zeros cancel, but you still have 55 over 17. Just leave it 55 over 17. You don't want to round it. One of the things you need to know about using a calculator is that you never round a problem within the problem. You only round at the very end. If you start rounding in the middle of a problem, you lose accuracy. And if you lose accuracy, well, think about it. We're talking about people's money here. Do people like it when you get the numbers wrong? No, right? You can't just tell somebody, oh, well, we were only off by, $270. I know, right? You can't just rip off somebody $270. All right, so now we could use the property of logarithms. We could take the log of both sides. So that's what we're doing. Why are we doing that? Because our variable is in the exponent. The variable is next to the 365 in the exponent. We need to bring that down. So if we take the log of both sides, then we use the power rule. So now the 365t can be brought down in front of the log using the power rule. Now we no longer have t in the exponent. Get t by itself by dividing by everything that's around the t. That way it all cancels. The log part cancels and the 365 cancels, and all we're left with on the right is a t. And then now all that stuff on the left, just got to type it into your handy dandy calculator, and you should get about 14.7 years. I just rounded it to the nearest tenth. You know, we could probably be more specific and figure out how many days it is if we wanted to, but we'll just leave it like that. In reality, you would probably want to find out what day it's going to be, right? It's going to be on June 13th or something like that. Well, 0.7 is more than half, so probably more like, I don't know, late July, maybe August, probably August, right? That would be 0.7 years. Okay, let's do another problem. All right, last problem. The number of grams of a certain radioactive substance present after T hours. Okay, so T is in hours. Again, when you're reading a word problem, I don't really write down the whole word problem. It takes too long, right? But I start making little notes. So you might want to put T equals hours. All right, and then here's our equation. A equals, I would definitely write that down, right? The equation is important. A naught, we know that's the initial number of grams. All right, here's more information. How long will it take 5,000 grams to be reduced to 2,500 grams? Okay, so we have two values of A. We have A naught and just regular A. A naught is the initial number. Which one of these is what we start with? Which one is the initial amount of grams? Right, it's the 5,000. Because we want to know how long will it take 5,000 to be reduced to. So we're starting with 5,000. That's our A naught. And then on the very left is A. That's going to be the 2,500 grams. That's what we end up with. So let's put those two numbers into our formula. All right, 2,500 equals 5,000 e to the negative 0.025 t. We got to get the e to the power by itself. So divide both sides by 5,000. The 5,000 on the right cancels. On the left, you get 0.5 or 1/2. You can leave it as 1/2 if you want to. Now, when we see e, we're going to use ln, so take the ln of both sides, the natural log of both sides. So ln of 0.5 equals ln e to the negative 0.025 t. Use the power rule, bring the exponent in front on the right-hand side. Now, do you remember what ln of e is equal to? Right, it's 1. So we just have to divide by negative 0.025. Again, ln of e is 1, so that's t times 1, which is t. Type that into your handy-dandy calculator. And you get 27.7 hours. Again, I round to the nearest tenth. I didn't put that in the directions, but always pay attention to what your teacher wants you to round to. In this section, I think I just did tenths everywhere. That's it. Wasn't too bad, right? I'll see you here for the next video.